Okay, one question that you had was in the review packet on section 7.1 A here, number 2. It mentions about supposing that two different statistics, we're calling one statistic A and one statistic B, are used to try to estimate a population parameter. So in other words, we could be talking about means, we could be talking about proportions. I'm just going to go ahead and use means for this example. So you've got some different sample means that you are trying to use to estimate where the actual location of the true population mean would be located. And it says here that statistic A has lower bias than statistic B. Now, what bias is that means when you take your samples, the majority of your samples are kind of all lopsided on one side of where the true population parameter is located. So if statistic B has a lower bias, it means that your sample means are balanced a little bit better on each side of where the true population parameter is, versus statistic B, it's a little bit more lopsided. Okay, so we want to keep that in mind. It's more evenly on each side for A, a little bit more lopsided for statistic B. Also, statistic A has higher variability compared to B. That means your sample means are spread out a little bit more. So they want us to draw two parallel dot plots, okay, two different kind of beginnings of sampling distributions here, showing 8 dots, 8 values for each statistic that would kind of be consistent with this description here. So keep in mind, each dot that I'm drawing represents technically an X bar, a sample mean. So the first thing is that statistic A has lower bias than B. So we are to assume that the true value of the population mean is right where that arrow is. So that's kind of where mu is actually located. But I'm going to go ahead, we have to put 8 of these. And so I want to put some on each side, and there's not one exact way to do this. What do I have? I have 4 of them there now. Okay, so we'll just say roughly, there I put 8 dots, each one representing a sample mean from a sample I would have collected. And you can see I've got 3 of them on the left side of where the true value lies, and there's 4 over here on the right side. Now when I draw this for statistic B, I'm going to make them a little bit more lopsided. I also, since statistic A has higher variability, that means the spread is bigger from my lowest mean value to the highest one. So I want to make it a little bit tighter for statistic B here. So maybe I'll make one of the values spot on with mu, but then I'm going to lump the majority of them on one side. And you can see that I've got them tighter together. There's less variability. So this would be one example of a dot plot that you could draw that shows how this has more spread, more variability, but less or lower bias because they're evenly on each side. This one has higher bias, but less variability. So that was kind of number 2. Again, didn't have to look exactly like that, but they wanted 8 dots in each of those 2 dot plots there. And then you also were wondering about number 3, particularly with part D. So I'm just going to lay out what this is talking about here at the beginning, and then we'll jump down to part D here. It says a large pet store that specializes in tropical fish has several thousand guppies. The store is claiming that the guppies have an average length of 5 centimeters. Now keep in mind that's talking about an average length here. Okay, standard deviation 0.5 centimeters. Says you come to the store and you buy 10 randomly selected guppies, and this is from your sample. You find that the average length of your 10 guppies is 4.8 centimeters. So this is making you maybe a little bit suspicious of whether the true average fish length is maybe not what the store is suggesting. It feels like it's a little bit under. So we want to explore this a little further. It says you assume that the length of the guppies is normally distributed, and you use a computer to simulate 20 samples of taking 10 guppies. So again, each of these dots that you're seeing represents you averaging together the length of the 10 guppies for one sample. Okay, and there are 200 dots here in this dot plot. And to part D, D is saying, do you think that the store is being honest about the length of its guppies? Remember, their claim is that it's 5 centimeters. And so when it asks you to justify your answer and you have dot plots like this, we want to go all the way back to the beginning of the year when we said 5% is what they kind of use in statistics as your benchmark. Okay, so please keep in mind anything happening more than 5% of the time, just by random chance, which is what a simulation is, that's not considered that unusual. Anything that happens under 5% of the time, though, that is considered pretty unusual, and that's when we want to start saying that we're kind of alarmed that that happened. Now, what you're comparing in this dot plot is you want to find all the dots that are at what the dot would have been from the one sample that you took, or more extreme than that. So when we took a sample of 10 guppies, we got 4.8 centimeters. So that would be right here at this mark. You can see there were 4 actual dot plots here from this simulation that landed exactly at an average of being 4.8 centimeters. Okay, so we were kind of not sure if the claim was totally accurate or not when we got 4.8. Certainly would also question if it was anything smaller than an average length of 4.8 as well. And so all the dots that you're wanting to focus on would be everything from 4.8 centimeters or anything even shorter than the 4.8 centimeter mark. So you can see I kind of circled or boxed those in. If you count how many dots there are in that section that I circled, there are 21 dots out of a total of 200 dots from this simulation. So I want to try to figure out, okay, look, 21 out of 200 just random chance simulations here, I got the same thing or even shorter than what I got when I did my sample of picking 10 guppies from the store and calculating their average length. So what we're really after here is we want to try to figure out, is 21 out of 200, where does that fall here? Well, 21 out of 200 is 10.5%. Okay, so our justification, like if this was a question on the AP test, you could say something like 21 out of the 200 sample means in the simulation are less than or equal to the 4.8 simulation, or sorry, 4.8 centimeters that we got. Okay, now since 21 out of 200 is 10.5%, and that's well above the 5% mark. Okay, since 10.5% is greater than 5%, this isn't, you can either say an unusual or an unlikely occurrence. It's not an unusual occurrence. Therefore, we shouldn't be alarmed. The store is likely being honest. Okay. Now, had the dots been very much fewer than 21, and then when we divided this, we got a number that fell under the 5% mark, then we would say, okay, now that the percentage is under 5%, we are alarmed now, and we would say that maybe the store is not totally being honest. So it's all about how, when you perform a simulation multiple times, like here 200 times, how many of those 200 did you get the same thing from what you got in your sample or more extreme? If that's happening pretty regularly, then it's a normal occurrence to have gotten an average length to be 4.8 centimeters, and we don't need to try to claim that this store is being dishonest.